Hello and welcome to the next episode of my Learn With Me Opsix series. So far we've talked about the basic features of the device. We've had a quick first look and overview of the panel and the build quality. We've experimented with different waveform types, different operator modes. We've designed some FM sounds, both 4 and 6 operator, and we've also made a subtractive synth using this device. One thing worth noting, and I guess I didn't really bring it up before because I didn't notice it, someone pointed out that the keyboard noise was quite loud when I was playing, and I realized that this is not really an artifact of my setup, but an artifact of this keyboard. So specifically, when you strike a key hard, most keyboards will give you a loud sound. This is no different than that, but in this case, when you release a key quickly, you get a sort of loud springing type of noise when you let go. This may be related to the release velocity that this keyboard supports, but the keyboard is actually quite a bit louder than some other keyboards that I've tried. So just for your information, it's worth knowing if that matters to you. So in any case, what are we going to do this episode? This episode, we're going to explore user algorithms. So let's make an init patch and I'll explain what I mean by that. So first, let me talk about what an algorithm is. So an algorithm is this little arrangement of blocks here. What exactly are these? Well, each one of those blocks is what we call an operator. An operator is an oscillator, an envelope, and some routing mechanics, and possibly some other controls. The way they are arranged here represents a signal flow top to bottom. When there is an input to an operator, if it's in FM mode, it will be modulated by that operator. The different other operator modes will have different behaviors. On the bottom row, all of those operators output to the mixer. So this bottom row we call carriers, and in this mixer section they're represented by this pinkish color. Anything that is not on the bottom row is modulating something else, so we call those modulators, represented by the purplish color here. So we have a selection of algorithms, the first 32 of which were taken from the DX7. One of the reasons, I think, for the algorithm choices on the DX7 was there is a cost for every modulation that's occurring with respect to a routing of an algorithm. And I think they were chosen to represent a diversity of routings, but also to minimize the number of routings that needed to be done. I believe that at most there are 7 of them occurring in any of these algorithms. On the Opsix, there are a set of other fixed algorithms which got added on top of those. So the first 32 are the DX7 algorithms. The next 8 are Opsix specific algorithms, but the 41st algorithm is actually the user algorithm. Notice the user algorithm actually has something set here. Note that there is an arrow in the bottom row and there is a square up there. And also note that operator 1 is in carrier mode, operator 2 is in modulator mode, and everything else is switched off. So let's first understand what this means. The bottom row represents the outputs to the mixer, and the columns represent operators 1, 2, 3, 4, 5, and 6. So the output to the mixer, operator 1 is outputting to the mixer, and none of the other operators are. Now going across, we have 1 row per operator, and each column represents how much it is modulated by that operator. So in the first row, it means operator 1 is being modulated by what? It's being modulated by operator 2. So operator 1 is our carrier, operator 2 is our modulator, just as you'd expect. Why might you want to use a user algorithm? Well, one reason is that in theory, you could have all of these 6 by 6, as in 36 routings, connected up. So that is an algorithm which is much more complicated than any of the preset algorithms that were available. Another reason, which I will illustrate, is that in all of the other algorithms, the amount of signal that is transmitted is determined by the output level of that operator. In the user algorithms, those can be attenuated, as in not 100% of that signal needs to be transmitted. Where the entry in this matrix is fully filled in, that is a 100% level, but it's not always 100%. So the question you might ask is, okay, well, how do we go and edit this? Can I do? No, nothing there. Well, it's hidden away in the miscellaneous menu. User algorithm, yes. So now we're in the user algorithm edit mode. Conveniently, the operator mixer, it continues to operate in this mode, and the keyboard continues to operate in this mode. So let's go back to a completely initialized state. So operator 1, this encoder represents feedback modulation of 2 to 1. So I'm going to turn that all the way down. Notice as I adjust it, the figure changes here. So what happens is it draws a box at a certain size, and then that gets filled in, first in outline, then in solid, then a bigger box. It gets filled in from outline to solid, then a bigger box filled in. So let's turn that all the way down. And you may say, well, how do we send it to the mixer? And that is a second page. And on this second page, I can turn that to off. So now, none of the operators are sending to the mixer, so there is no sound. Okay, so that's the basics, but let's design a sound here. I'm going to try and build this sound up, starting with one operator, and then on demand, adding more operators or modulators to give us the sound we want. And the sound I'm going to go for is a pad. So first I'm going to bring in operator 1 only. Operator 1, let's just leave it in sine mode for now. Let's turn it up. So, single sine wave, pretty straightforward. Let's adjust the envelope shape first. So let's give it a bit of an attack, a bit of a decay, and a bit of a release. Okay, and let's see, maybe add some feedback to that. So notice this feedback that I've just set is in the mode menu, and this is an internal feedback. So this internal feedback is not affected by the level at the output or caused by the envelope. So it's a static shift. But if I go back to my user algorithm edit page, I have an option for self-modulation here. So you may note you can hear the brightness increasing as that swell happens. That's because this self is not an internal feedback loop within the oscillator. This is a feedback loop around the entire operator. In other words, the envelope has had its effect. Okay. Note how the color has changed here. Why? Because this is now simultaneously a carrier and a modulator. I quite like the way that sounds already. I'm going to go and add a second carrier. So, go to page 2. Operator 2 is now on. So operator 2 is now a carrier. Let's say operator 2 is going to run at a lower frequency. So notice that at the moment, operator 2 has the default envelope. So let's go to the envelope, operator 2 selected. Let's make its onset even slower than the other one. I quite like it. Let's go back now to the, I guess you'll see, going to that algorithm edit page, user algorithm edit, is a little inconvenient, but it is what it is. I quite like that. And I might add now another carrier. So note here that normally I would have to commit to an algorithm up front. And if I decided that I didn't like the way that it was working for me, effectively I'd have to start again. Not here. I can start with a single operator and I can shape the algorithm any way I choose. So to me, this is one of the big strengths of this device, which is not immediately obvious. Let's go to the next operator. Let's turn operator 3 on as a carrier, that is. So let's go to the other page and let me have this at maybe double the frequency. Okay, sounding good. So let's look at the envelope there. Maybe I'll make it even slower. 4 seconds, 8 seconds, and then 3 seconds at the tail. Let's listen. Different key. Okay, so I think this is sounding reasonably good, but now I would like to start to add some modulation here. I'd like to add some different movement and different sounds. So what I'm thinking is I'm going to make 3 modulation sources, and all 3 of those modulation sources will affect all 3 of the operators, but I'm going to affect them to differing degrees. So let's start by setting the frequencies. I'm going to go for, let's say, 3, 5, and 7. So these, we call them ratios, and they are the ratio of the frequency of the oscillator in that operator to the fundamental note that I played. So these are the 3rd, the 5th, and the 7th harmonic. Now what I'm going to do is I'm going to go to these low-numbered operators, which are my carriers, and I'm now going to set in the user algorithm modulation amounts from these 3. So I'm thinking that I'd like, this is the middle frequency, the low frequency, the high frequency. So the mid frequency I would like adjusted most by the middle of these 3 frequencies. So that's operator 5. I didn't have it turned up. And let's have it modulated by the other 2 to other degrees. I'm going to go through and change the envelopes afterwards. So you can see the sort of symbols there, they're giving me a hint. So this one is the lower frequency one. So I'm going to have it modulated most by the lowest frequency of these, which is 4. And then a little bit less by this, and a little bit less by this. And then the next operator, that's 3, I'm going to have it modulated the most by the highest frequency one, less by the next, and less by the next. So at the moment, the envelopes for these modulators are cutting off quite quickly. So that's giving me quite a sudden drop in the sound. I'm going to go and change those, but for now I'm going to tweak these levels, the main levels, to just listen to the timbre. Okay, I think I like the way those are working. So now I'm going to go and I'm going to shape the envelopes. what I'm thinking of doing is having these, even though this is a pad and I've got it with a slow attack, I'm going to give these just a decay kind of shape. So let's go to the first one. And I think the lowest frequency I'm going to have lasting the longest. So let's go to this page. So there's going to be no attack on it. The decay, let's say, can last for 10 seconds, going all the way down to 0, and then release of 2 seconds. The next one can have a decay of 7 seconds and a release of 1.5 seconds. The next one can have a decay of 5 seconds and a release of 1 second. So let's just see how that sounds. Okay, so now I'm going to go back and adjust the levels of these operators, just to hear how they sound. I'm going to start with the bass one, actually. Then the mid. High. Okay, I think that's working well. I'm going to now add some velocity sensitivity here. So I think what I'm going to do is have the sort of central frequency to be the least velocity sensitive, and then the upper and lower frequencies to be a bit more velocity sensitive. So I'm going to go to the other page here, and I'm going to pick operator 1. Velocity sensitivity, this can be, say, 20. This next one can be sensitivity 30, next one can be 40. Then at the modulators, I'm going to do it a little bit more than that. So let's say 30 for the lowest frequency, 40 for the next, 50 for the next. So let's just try and play low velocity. Let's play high velocity. So another thing I think might be interesting is having these modulators, in addition to modulating these, modulate one another. So I think what I'm going to do is have the highest frequency one modulate the two below it. So operator 4 is going to be modulated to some degree. Operator 4 is going to be modulated to some degree by operator 5, and a lesser degree by operator 6. And then operator 5 is only going to be modulated by operator 6. So this is going to add the potential for a little bit more motion in the sound. Let me listen to it. Since I added the velocity sensitivity, I think this balance is a little off and the overall volume's a little low. So I'm going to go into miscellaneous, program miscellaneous. Turn up the volume a bit. Okay, I think that's sounding okay, and I'm going to revisit these levels. So let's try just the bass. Add the mid frequency. High frequencies in as well. Let's play in a higher register. So I think already I can hear that it gets a little bright high up. So to me that says time to put a filter in. Let's try the Poly 6 filter. And in the middle register, let's set the cutoff so it sounds okay. Now we're going to go up. And now we're going to adjust the amount of filtering in the high register and do the same in a low register. I think also I might like the volume of these operators to be a little bit different. So let's look here. So here we can set the volume of each of the operators in different registers. So let's experiment in a low register and let's try turning up and down the volume of operator 1. Let's go into a high register. Okay, let's do the same with operator 2, low register. High register. And finally operator 3, low register. Okay, so now we've adjusted how much of each of these carriers are playing in higher or lower registers, just to balance the sound out a little bit. So let's play in a middle register. So I might decide now that I think the attack overall is a bit too long. So this is a good place to use these kind of macro level controls. This control is going to adjust the attack of all of the operators. So if I turn this right down, I could turn it all the way into something playable, more like a keyboard sound. Okay, this sounded pretty interesting. Let's add some effects just to round this out, and then I think we'll be done. So we haven't really looked into the effects in great detail, but I'm going to try and bring in an ensemble. Okay, sounds all right. Next effect, I'm going to try for, tape echo, sounds good. I'm going to set the mix to 100 so there'll be no dry signal in here. Damping. Now turn the level down. Sounds okay. And maybe the shimmer reverb Turn it up to maximum. Okay, let's see how this sounds then. Play maybe in a slightly higher register. Okay, so I think we have gone from the thought of making something that's a bit like a pad through a sound, which was a bit of an organ sort of sound, and we've added additional modulations here. So this is a 6-operator sound, but how many modulation routings are? Remember I said the DX7, I don't believe any of the algorithms have more than 7 modulation routings. Obviously they have more mixer routings. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this already has almost twice as many routings. And as I mentioned, we can have all 36 in play here, which can add some pretty interesting movement and timbre complexity. Note that I haven't involved any of these envelopes. So we've got 3 other envelopes which I've not touched. We've got 3 LFOs which I've not touched. We have the whole mod matrix. Nothing's been done here whatsoever. So if we wanted to refine this sound, if we wanted to make it more playable, make it more expressive, then we could dive in and use some of those other capabilities. Maybe we could make the mod wheel do something interesting. Maybe we could animate that filter a little bit. Maybe we could make some velocity expression, even key release expression. There are a lot of possibilities, but today is not the day to be exploring those. Today is the day where we try and understand the user algorithm, and I hope we now do. So hopefully this episode was interesting to you. Hopefully you will join me for some more episodes where I try and learn the Opsix and figure out how to get the best out of it. In any case, I hope that you have enjoyed. I would like to thank you very much for joining me today and say goodbye for now.